Hi, so what I want to do now is I want to have a look at another aspect of timers, okay? So let's just think about our timer, looking at the data sheet again. So we've got our timer counter register here. It's counting according to the clock pulse, which is coming in from our prescaler and crystal through this count line. And of course, we've set up a comparator so that it counts to a specific value and then it rolls over and gives us an interrupt. However, there's a feature of this that we do not need to use. We do not need to use the interrupt if we don't want to. What we can do is we can actually get the overflow at this output compare register 1A value to actually trigger a pin, a hardware pin on the microcontroller, which means that we don't need to have any software involved in this generation of this output, apart from just initially configuring the timer and then saying, go for it. And we can ignore it after that and it will continue to do what we want it to do. So we're going to figure out how to use this pin here. And what we're going to look at is in the exact 1 second flash interrupt hardware output timer. Okay, so it's directly connected to this pin of the microcontroller, and that's on page 134. We don't need to use this ISR, but we do have to use the pin, which is for output compare register 1A. So we just pop back to the data sheet. We'll have a look at the pin configurations, and we'll look for the one that is connected to output compare register 1A. So we're going to find that output compare register 1A is port B.1. Okay, so it must be this pin. Okay, we don't have a choice of any pin we want to. With this microcontroller, this is what we have to use. Okay, so what we're going to do is, of course, we're not going to use the interrupts. So I know this isn't in your line of your notes, but actually I've just put this in there just to remind us that we don't need any interrupts. We don't need our timer interrupt mask register, and we don't need our interrupt header file. We're just going to configure the hardware pin to toggle on its own. So how do we do that? There's obviously a bit in a register that we have to figure out somehow. And so what I've done here is I've actually configured it. That's the pin, okay, or the bit in the register that we have to configure to make sure that it actually toggles output compare pin 1A, which is of course port B.1 of our microcontroller. So what's going to happen is I'm going to look at the data sheet. Again, always back to the data sheet for our reference. And there we go, timer counter compare register 1A. These are the bits here. And you'll find that what we've got is we've got compare output mode for channel A, compare output mode for channel B, so we can do things with channel A or B. And we're looking at channel A, and there are 2 bits to configure channel A, okay? So we're going to come down here and find out that these are the bits, and this is what we would do. So normal port operation, again, is when the power up of the microcontroller, it clears all our registers for us. That's normal port operation, and that means that it's a normal I/O pin that we have to configure ourselves, which means that output compare 1A is disconnected. If we want it to toggle, then we have to set 1A 0, and if we want it to clear on the compare match, we set the bits 1, 0, and if we want it to set on compare match, we trigger both bits. So what I've got here is I've decided to COM1A 0, so it will toggle. Okay, so that's what I've decided. It will toggle just by setting this bit here. So this is exactly what's happening. Output compare 1A is 62499, and this is actually just toggling away. I've taken this code, I've copied it straight into Atmel Studio. There it is there. I'll just delete this little line here because it's not really necessary. It was me playing with a few different features, but here they are. Here's our CDC mode, toggle, and I'm just going to compile that. And I'm going to stop share for a moment, and I'm going to tilt my camera down so we can have a look at the board and see that the LED is indeed just flashing on for 1 second and off for 1 second on. That's a second on and a second off, okay? So that was pretty straightforward. Now, what I want to do is I will go back to the screen share. Where's that? There. And we're having a look now at how we might figure out these values. Can you develop a mathematical model for calculating time accounts? And I try to avoid using the word formula because a mathematical model says that actually what we're trying to do is describe the behavior of what's going on in our circuit rather than just sort of thinking about this as a place to put numbers and get an answer. So what we've got is we've got, well, let's go back to our little piece of paper and our calculations again and see if we can figure out what this model might look like. Just tilt the camera back down again. My notes are all upside down, so I'll just have to go off screen share and excuse me. I'll just stop the share and I need to go back into my options for the video, video settings, and I'll just rotate this. There we go. Cool. So what we've got is, we've already talked about this. Our counter starts from 0 and goes up to our output compare register value. And at that point there, what we're happening is, at this stage, we've not got an interrupt happening, but we've got the pin itself, output compare 1A pin is toggling at that point. So this is what's happening here. We've got output compare 1A pin, which is port B.1, which is toggling at this time. Oops, just focus that. A bit more light on the matter. Now, what we've got here is the period of time that this is taking. So what is this? We've got our frequency and our prescaler. So there's our frequency coming in. I'll just tilt this so you can see that frequency coming in, and then we've got our prescaler value here. Okay, so we're dividing that by that to get this, and then we're actually using the period of this signal, not the frequency of it. So I want to inverse that. Okay, and of course that is therefore the prescaler divided by the frequency, and then I'm multiplying it by this number plus 1. Okay, so that's the times the compare value plus 1, and that will give us the period. Okay, now remember, this is the period. This is this period here. Okay, this time period here, t. Okay, whereas what's happening in the output pin is that, say, if this is low, this is high, this is low, this is high. This is actually a full period here of 1 over f, our output frequency. So just remember this, be very clear about whether you're working out this period of time or the combined period of time. In this case, we're just looking at this period of time here. And so I'm just going to reconfigure this so that we've got a model we can use to actually work out the compare value. So, compare value equals the period times the frequency over the prescale, right, and minus 1. So we can just drop, sorry about that, there's my video. So our compare value equals the period times the frequency over the prescale minus 1. So a little bit simple algebra there. And what we've got now is a way that we can actually model this timing period. So if I want something different in my microcontroller now, what I'm going to do is that this is flashing on and off 1 second rate. So say I want this to have a period, an on period and an off period, either or as say half a second. So we can just pop this into the formula and or the model, is a bad word again, eh? So the mathematical model that describes the behavior of our circuit, and we can work out the value for that. It's fairly straightforward. And what should we do? We should do a value then. So if I want half a second, I'm going to put in period is 0.5 times the frequency, which is 16 megahertz, over the prescale. Well, the prescale at the moment that I'm using is 256, and then I will subtract 1 from that. So that's 8 million over 256. So I'll just pop that into my calculator. Open that up, 8 million divided by 256 equals 31,250. Subtract 1 gives us 1,249 as our compare value. Okay, and that will give us a half second. So I'm going to share the screen again. Just get to my toolbar here and share screen. Right, so we're back here again, and where's my annotation? And I'll drag ML Studio to the front again. So I'm saying instead of using 62,499, I'm going to use 31,249, which actually makes sense because that's the relationship of divide by 2 there. So now I just compile that. Okay, now you should be able to see the little image there, and I will upload that. There we go. And now it's flashing at half a second. Okay, so I'll just come off, stop the share there so you can see what's going on. So this is a fairly straightforward way of modeling the behavior of a timer, but again, just be very careful about trying to memorize this sort of thing, and rather than work from first principles. Cool. We'll stop at this point. Cheers.